Today is a big day. We'll be finishing up our DTA, dynamic traffic assignment journey here. So we're going to finish up with this third part. So far we've already covered adding in all the different network objects that are associated with DTA. So looking at adding in the nodes and zones and parking lots. And then last time we took a look at all of the different parameter settings that we have for like the path choice and search. And then today we're going to take a look at looking at the DTA results and then fine-tuning the network. So just to recap, dynamic traffic assignment is a way for demand between different origins and destinations to get assigned to different paths. And since this path assignment will depend on items like the path distance, the travel time, and any financial costs associated with the path, this is an iterative process that will take multiple simulation runs in order to reach convergence. So today we'll be just taking a look at, once we have everything set up, how we can go through and actually run this assignment method. And then taking a look at the results that come out of DTA, and then doing some fine-tuning and adjustments for the model. After that, we'll take a look at what it means for the model to find convergence and how we can check some of the status of those within the model itself. And then once we've found convergence, we'll go through how we can go ahead and deactivate that assignment so that we can finish up the simulation run and collect our network data for multiple seeds. So first up, we'll just take a look at how we can run DTA once we've set up all of our network objects and parameters. So most of this setup will be done within the simulation parameters window itself. So the first part here is going to involve setting up the time period, so setting up how long that simulation duration will be for, as well as the start time. And it's really important for this start time here to match the from time that's been set up in the matrices that you've created for all of your origins and destinations. And then you'll just want that time period to also represent that duration, whether you have just a single matrix or multiple matrices kind of covering that whole simulation duration. And then the next item you'll want to change is the number of runs. So in this case, since we'll be running this assignment multiple times in order to reach convergence, you'll want to set the number of runs to a relatively high value, typically something greater than 25. And this, of course, will vary depending on how large your network is, as well as the number of paths that you have between each of the origin and destination pairs. And you'll also want to set that random seed increment value to 0 in order to prevent the seed from changing. And this will just prevent any additional variability, such as how vehicles arrive in the network, for occurring in order for us to go ahead and be able to reach that convergence in the network. And then lastly, we'll take a look at the dynamic assignment volume increment parameter. So what essentially this will do is allow us to begin our path and cost search process with a reduced demand and then increase this throughout the iterations. So this can be useful because the very first few iterations that you run are going to have a very small path set. And what can happen is if you place 100% of the demand onto the network all at once, that could lead to congestion occurring on what might normally be the actual best path in the network. So this will just allow us to kind of slowly add the volume in. And so this will actually be tied to a value that we kind of talked about last time within the dynamic assignment parameters. So here's where you can set up what that initial volume will be, like say 10%. And then based on that increment value, each iteration will then increase by that amount until you reach 100%. And then from there on out, the rest of the runs will just be run with the full volume in the network. And that will just help you build up that path set and have a better estimation of all the viable paths in the network. All right, so then once you have all of those simulation parameters set up, and then you can go ahead and run the simulation and start to take a look at some of the DTA results. So the two most direct results we can take a look at are OD pair results, which will be information about the different origin and destination pairs, such as the number of vehicles that travel along between those pairs, and some information about the time and distance. And we can also take a look at all of the actual paths that get generated as part of this assignment process. So in order to write out the OD pair results, you'll need to go to the Evaluation Configuration menu option, and then within this window there's a section here for OD pairs where you can just check the Collect Data box, and then you can define the from and to time as well as the interval that you want to collect these results for. And then in order to view the results, you can just go to the evaluation result list and open up the OD pair results, which will open up this list. And so here's what that list will look like overall. So we'll have the time interval here depending on what you defined back in the configuration settings. And then we also have all the different OD pairs. So this will be the from zone and then the to zone. And then this first group here is all of the results aggregated by departure time. And so we can look at different results such as the travel time for that particular OD pair, as well as the delay time and relative delay, and the number of vehicles and the total distance traveled between that OD pair. And similarly, we can also look at this aggregated by vehicle arrival time. And so all of these results will be collected once that vehicle reaches its destination parking lot. And if you'll recall, we can have a zone that does have multiple destination parking lots. So those results will all be combined for each of those OD pairs. And then if we want to take a look in more detail, maybe at all of the different paths that were generated, we can go to the traffic menu and then select dynamic assignment and then paths. And this will open up just a list of all of the paths that were created. And this will be for each of the parking lots. So you'll notice there that we've got the from parking lot and the to parking lot number. And in the network editor, those paths will be highlighted so that you can just go through and visually check some of the paths just to make sure they seem reasonable and kind of what you are expecting to see. And there are a lot of different attributes that you can also take a look at within the paths themselves. So you can also look at the distance reach of the path and any financial cost that was applied to the path, as well as the travel time, both for the current iteration and the last iteration, along all of the edges that make up the path. And so those edges, again, are just the sequence of links that occur between and within the nodes as the vehicle is going along that path. And then we can also see both the travel time for the path for the current iteration, as well as the travel time for the previous iteration, which will be marked there with that old name there. And so this will be also the values that will be used if you do have that use volume old selected as the path choice model. And then finally, we can take a look at just the number of vehicles that were assigned to each path, both again for the current iteration and for the last iteration. And you can add all of these attributes also for different time intervals. So right now I'm just pulling these for the very first time interval that's defined, but you can add these if you want to look at each of the different time intervals or pull information for a particular time interval. All right, so now that we have taken a look at the directly related DTA results, then we can go ahead and make some other fine-tune adjustments to the model. So for example, if you're looking through your results and you notice that a particular roadway section maybe has more traffic than you expect, you can apply a surcharge to the links and connectors. And this will just add additional cost onto those to kind of deter vehicles from selecting that path. You can also remove unwanted routes from the path search, either by applying these route closures, which will be for a specific link sequence that's going to cover multiple nodes, or you can close an edge, which will restrict vehicles from using an edge either between nodes or a turn that exists within the nodes themselves. So these are just a few options that we can do to kind of fine-tune some of the vehicle behavior once we've taken a look at those results. So in order to apply any surcharges to the links or connectors, this can be done either directly in the link or connector window. So if you double click on the desired link and go to the dynamic assignment tab, there'll be two options there for adding a surcharge. They'll just be numbered 1 and 2. And you can use these if you wanted to keep track of different surcharges that may have been added for a particular reason. And you can also add these in the link list if you go ahead and add in the surcharge 1 and surcharge 2 attribute. And then for the route closures, these can be added by selecting that vehicle routes from the Network Objects toolbar. And then you'll just select that little drop-down icon there, and you can change the selection to closure. And these routes will be added just like any other like static or partial route, where you'll just select the start point and then the end point. And from there, you can also edit the route if you want it to take a particular path. For example, this can be useful if you want to close off kind of this behavior from happening on a freeway where vehicles maybe exit and then just kind of take the exit ramp and then the on ramp to come back onto the freeway. And just a note when working with these route closures, that in order for vehicles to kind of obey these and take these into account, another path will need to exist on the network for that particular OD pair. So if you do add a route closure and notice that vehicles end up still taking it, it's most likely because they just don't have another path option to choose from. So if you want another path to kind of be forced to be found, what you can do is try and run the DTA process with the alternative routes option turned on. So hopefully it'll pick up another option. And then another way is if you did a temporary edge closure, maybe closing this through edge at this point right here. And this will force another route to be found if it exists. So what you can do is just temporarily run one iteration with that edge closure in place. And then after that, after another path has been found, then you can go ahead and remove that edge closure and add in the route closure. And in that case, then vehicles will then pick up that alternative route that was found and will take this route closure into effect. And then if you do want to go ahead and close one of these edges or turns, the easiest way to do that is by opening up the node list. And then in the drop-down here for the child list, you can select either edges for dynamic assignment or turns for dynamic assignment. And on the right-hand side is where all of these edges or turns will show up. And then you can just check the close attribute if you want to prevent vehicles from either taking an edge that exists between two nodes, or if you want to actually close a turn that's going to exist within the node itself. All right, so after we've kind of gone through that process of reviewing results, fine-tuning the model, reviewing results, and fine-tuning the model, at this point, then we can start to run the model for convergence. So what exactly is convergence? Well, in this case, since we're trying to run this path assignment that's going to take the travel times into account, which are going to change between the iterations, convergence will be reached once we have kind of a stable state. And this will be determined based on the settings that are set up within that dynamic assignment parameters window. And essentially what we're looking for here is for the travel times either along the paths or the edges, or for the edge volume to not change significantly between the different iterations. And so this can be checked in a couple of ways, kind of at an overall level with the convergence file output. And then you can also check within the path list to see what paths and edges are meeting that convergence criteria. So in order to print out that convergence evaluation file, if you return back to that configuration window, you'll need to select this direct output tab, and then you can check write to file next to convergence. And this will write out a file in the directory specified up here, and that file will have a .cva extension. And this is what that file will look like. So you can go ahead and open that either in a text editor like Notepad++, or if you want to bring that into Excel, you can do that as well. And so this is kind of broken up into a few sections. The top part here is going to contain any of the volume difference information, both for the edges and the paths. The second section will then contain the travel time difference information for both the edges and the path. And just wanted to kind of take a close-up look at what some of these values mean. So essentially we've got each row that's going to refer to a different time interval in the simulation. So for example, like 600 seconds to 1200 seconds. And then each column is going to refer to either a difference in volumes or a difference in travel times, depending on if you're looking at the top section of the file or kind of the bottom section of the file. So here's just a quick example. So in this case, we're going to be looking at edges that contain a volume difference between 3 and 5 vehicles. So we're just going to look at this particular class information here. And then if we take a look at this time interval from 1800 simulation seconds to 2400 seconds, we will find that in this particular iteration, there were 13 edges with volume changing between 3 and 5 vehicles. So again, this file is just a quick way to kind of see an overall glance at how the network is behaving differently between each of the iterations, and can just give you a quick overview to see if most of your edges or paths are kind of within a smaller, kind of containing smaller differences, or if you have some paths or edges that maybe have a significantly higher difference in vehicles between each of the iterations. And then at the very bottom, we have another couple of lines here that kind of tell us about the overall convergence criteria. So depending on which option you have selected, you'll have data displayed down here. So in this case, I was using the travel time on paths option. And you'll see here that the first two settings have to do with the percentage of paths that met that convergence criteria. And then you can also see this percentage weighted by volume. And then similarly, if you were looking at travel time on the edges, here's where you can see the percentage of edges that met that convergence criteria, as well as that percentage weighted by volume. And then finally, here is where you can see the percentage of edges that met the volume criteria if you have that one selected. And then on the right-hand side, there will be this assign convergence attribute as well. And this will just tell us overall if this run has converged or not. And then once you've kind of taken a look at the overall convergence information, you can go ahead and look at this in more detail on the path and edge side. So if you go back and open up that path list, you can add this convergence attribute here, and this will have a check mark next to any of the paths that met that convergence criteria. And then if you want to see information about the individual edges, which can be really helpful if you've got a lot of longer paths and you want to see maybe what section of that path is not converging, what you can do is change this drop down up here to edge sequence, and all of the edges will show up in this right-hand child window. And here's where you can see whether they met that travel time convergence criteria or that volume convergence criteria. And then once the simulation has met the convergence criteria that you have set up, you can set up just a little selection box to ask you what you want to do next once that convergence has been reached. So you can either choose to just stop the simulation, or you can choose to continue and try to meet convergence again, or continue until the end and you finished out all your runs. So once we've had that convergence met, then we can go ahead and take a look at deactivating that assignment. At this point, our path set is really complete, so we'll just need to turn off that path search from happening for any further iterations, and also make sure that our demand has been set back to 100%. And so that way we don't have that kind of iterative volume adding up over time. So if we go back to the Dynamic Assignment Parameters tab, here's where we can uncheck that Search New Paths option. And then we can also uncheck any of that volume scaling that we had selected. And then at the bottom of the Files tab is where we'll want to uncheck the Store Costs and Store Paths. And what this will do is it will prevent Vissim from changing any of these cost and path files that get saved right into the directory that your file is. So then for any future runs, it's just going to go back and reference the path and cost information from these files that have been saved. And then on the simulation parameter side, we're just going to want to go back and change that number of runs to a more manageable number to collect reliable simulation data. So this is typically something between 10 to 20 runs. And then we can also increase that random seed increment, and that way we'll have, runs will be changing their seed for each iteration, which will allow for that variability to happen again, where vehicles will arrive in different patterns and pick up different speed profiles. And then finally, we'll just want to set that dynamic assignment volume increment back to 0 in order to prevent the demand from changing anymore once we're collecting evaluations. So then at this point, we can go ahead and run the simulation just like you would if you were running a static assignment model, and you can go through and turn on all of your other evaluations and collect your network data. So let's go ahead and take a look at an example file that we created. I'm just going to go ahead and pull that up. So in here, we've added in all of the required nodes at any of the decision points that are occurring, as well as the network entry and exit points. And then we've also placed all of the parking lots in here that are going to be tied to the different zones that we've created. And we also have the matrices set up. In this case, we're just using a single matrix that is going to have all of our demand values for each of the origin destination pairs. And in this case, I've already run the simulation multiple times in order to reach that convergence. So we can go ahead and take a look at some of the paths that got generated here. So again, we'll just go back to the dynamic assignment drop down here and select path. And this is where we can see all of the different path information that was generated. And if you select that wrench icon, here's where we can add in additional attributes. So this is where we can take a look at items like the distance, or if we want to take a look at the static cost and the path travel times. And then we can also look at that convergence criteria, again, both on the path level and also for each of the edges within those paths. And then one other thing that we also did in this model was add a couple of those route closures. So I'll just pull those up here. Again, just going to the vehicle routes option over in the network objects toolbar. And we've got a couple of route closures here. This first one is to kind of prevent vehicles from doing that off-ramp, on-ramp maneuver. In this case, again, these route closures will prevent vehicles from taking a specific link sequence that spans multiple nodes. And then I have a second one that here, for any of these vehicles that were kind of making this U-turn to try to get to the freeway, instead of wanted vehicles to take this other path that would just take this regular turn to the on-ramp. All right, and then as part of the upload, once we have completed this webinar, we'll include this file as well as another file that does have that dynamic assignment kind of deactivated so that you can go ahead and compare both of those networks.